Good afternoon, guys. Welcome back. Okay, so guys, this is the last topic of chapter 10. It's going to be a very nice, short and sweet topic as well. It's called exponential equations. So, guys, an exponential equation is an equation where the variable that we're solving for is in the exponent of the equation. So, in all three of these guys, we have like an x in the exponents over here. Okay, so we have to learn how to solve these guys. Now, we're going to find in this topic, guys, these are all very, I can say very cooked examples in the sense that if you look at the number 81, we're able to write 81 as 3 to the power of 4. Okay. Now, again, 81 was kind of chosen carefully in this example because we can do this. Okay. Now, obviously, guys, we can't always do this. Okay. So sometimes, like you have a number. So, say for example, this number was like 72. Well, we can't take 72 to the power of 3. Okay, it's just not going to work that way. So we have to learn something called logarithms, which is the next chapter, in chapter 8 in this course. But for these examples, we're able to always go what we call convert these guys to a common base. So the idea over here, if we have 3 to the x equals 3 to the power of 4, and the bases are equal, this means, therefore, that the exponents must be equal as well, and therefore x equals 4. Easy enough. If we look at, for example, b here, 32 is the same thing as 2 to the power of 5. Okay, so in this case, these two powers are the same. They're both base 2. That means x minus 4 is going to equal 5. Add 4 to both sides, and that means x equals 9. Okay, so again, in this case, we're able to convert both sides of the equation to the same base. A little bit trickier, for example, C. It's trickier just because like these examples are fractions, and fractions are always more difficult. But 4/9 is the same thing as 2/3 squared. We still have the power 3x minus 1 like this. 32 is 2 to the 5th, and 243 is 3 to the 5th. So this guy is 2/3 to the 5th, 2x plus 5. That means we have 2/3. I can multiply this through. It's going to be 6x minus 2 equals 2/3 10x plus 25. Okay, so these powers are the same. They're both base 2/3. That means our exponents are going to be the same. Subtract 6x from both sides. Subtract 25 from both sides. That means we have negative 27 equals 4x. Divide by 4. Negative 27 fourths equals x. Okay, so all pretty straightforward, these ones. Okay, we can convert them all to the same base. Same idea, for example, D here, just a little bit more complicated. 3, 27, and 729 are all going to be base 3 numbers for us. So we have 3 to the 2x. 27 is 3 to the power of 3. 729 is 3 to the power of 6 to the x minus 3. Okay. Now, if I'm multiplying these two powers, that means I can add these exponents. And on this side, I have 3 to the 6th to the x minus 3. That means I can multiply these exponents over here. So now the bases are the same. They're both base 3. Therefore, 2x plus 3 equals 6x minus 18. Subtract 2x from both sides. Add 18. Divide by 4. Our solution is going to be 21 over 4. Okay, similar idea for this question. 25, 625, and 125 are all base 5 numbers. So step 1 is going to be put everything in terms of base 5. So guys, 5 to the power of 1 is 5. 5 squared is 25. 5 cubed is 125. And 5 to the 4th is 625. And that's where those numbers came from over here. So on the numerator, we get 5 to the 2x minus 6 over 5 to the 8x plus 20 equals 5 to the 3x plus 21 over here. Okay. Now guys, common mistake here. When we're dividing these two powers over here, we need to remember that we're subtracting the exponents. We're not dividing the exponents. So what this becomes is 5 to the 2x minus 6 minus 8x plus 20 equals 5 to the 3x plus 21. Over here, we get 5, 2x minus 8x is negative 6x. Negative 6 minus 20 is negative 26. So now these guys are both base 5. So therefore, negative 6x minus 26 equals 3x plus 21. Subtract 21 from both sides. Add 6x. And we get negative 47 over 9 is our solution to this equation. Okay, so looking at this guy over here, so I'm going to write out my powers of 6 here. So if we have 6 cubed, 6 times 6 times 6 is 216. That means 6 to the negative 3 is going to be 1 over 216 over here. Okay, so we're going to use this exponent rule here to deal with this 1 over 216 here. So 1 over 216 is the same thing as 6 to the negative 3 to the x minus 4 equals 6 squared to the x plus 3. Negative 3 times x minus 4 is negative 3x plus 12 equals 6 to the 2x plus 6. Okay, so the powers are the same, are equal. So the bases are the same, therefore the exponents must be the same. So therefore negative 3x plus 12 equals 2x plus 6. That means 6 is equal to 5x, and 6/5 equals x. All right, guys, so this is how these type of equations work. We need to write it so that we want two powers equal to each other, which have the same base. And that means we can kind of just drop the bases and make the exponents equal to each other, and then solve for a variable that way. Okay. So guys, chapter 7 is definitely a pretty short chapter over here as well. And as always, guys, if you have any questions, please let me know, and I'll help you out with those.